Hello everyone and welcome back to Up360 Circuits, your go-to channel for electronic tutorials, embedded systems and practical IoT projects. In today's project, we are building a smart IoT environmental monitoring and control system using an ESP32 microcontroller, the DHT11 sensor, some jumper wires and a breadboard. We would also be using an MQTT communication and a Node-RED dashboard platform. With this system, we are able to measure real-time temperature and humidity, send data wirelessly over MQTT, visualize sensor values on a live web dashboard, and remotely control an onboard LED from anywhere. So if you are interested in IoT, smart monitoring systems, or building real-time connected devices, then this project is a great example of how these work together. Now I'm going to explain how the system is connected step by step. The DHT sensor is connected to the ESP as follows. So the DHT on the breadboard, and then connect the VCC pin like this to 5 volts or VIN on the ESP32. Connect the data pin to GPIO4 on your ESP32. So look for GPIO4 labeled D4. Then we also use a 10K ohm pull-up resistor connected to the data line. So just right under your first jumper wire connected to the data pin. Okay, and then we connect the ground pin to ground. But then the other leg of the resistor also has to be connected to the VCC pin. So to do that, you have to jump it out. So you unplug this and just jump out a VCC, and then get another wire for your VCC pin, connect it to the VCC and then to the jumped out one like that. And then finally you can connect the second end of your resistor to the VCC. Okay, and then we just connect our V in. Now that our DHT is connected, we connect the ESP to our monitor or laptop, depending on what you're using. Like that. Now our ESP32 is powered up, and this allows the ESP to read temperature and humidity in real time. Now we'll move on to the Node-RED platform and set up both the web server and the dashboard. To use Node-RED, you have to ensure that you have Node.json installed and also Node-RED, and that you have both installed and open. So now we'll move on to the server. As you can see on the server, we have 3 sections: the node sections, the front and center workspace, and the debug section. Just going to go on and clear all of this data from my testing. And in the node section, we have different nodes grouped under different headings, but today would only be using the MQTT in, the MQTT out, the button nodes, the function nodes right here, and the gauge nodes for our temperature and humidity readings, the gauge nodes. So first thing we're going to do is you drag out an MQTT in just like this, double tap and drag out. I already have mine on the workspace, but I would show you how I configured it. Once it's dragged out, you double click it and then you set your server. Today we are going to be using the broker.ivemq server. So you type that in, then you subscribe to a single topic and then add your topic, which would be the ESP sensor. Type it just like that and then click done. Then we'll drag out the debug node like that, just like we did the first, and then connect it to the ESP sensor. Then we drag out two function nodes for the temp and the humidity, just like this, and then configure them by double clicking on it. Type in message.payload is equal to message.payload.temp, then you return message so that they can get readings, temperature readings from our ESP32. Same for the humidity function. Double click to configure it. Add in message.payload is equal to message.payload.hum and return message just like this, and save it. Also, we drag out our LED buttons from here under the dashboard too, just like we did with our function nodes and our MQTT in, and then just have it on the workspace. We drag out two buttons, one to trigger the LED on and one to trigger the LED off. Then we also drag out an MQTT out node from here, just like that. And then you have the LED on and LED off connected to your MQTT out. The MQTT out would be configured just like we configured the MQTT in. So we add our server, broker.ivemq, and then we add our topic, esp.led, so that we can receive commands from the MQTT, just like that. So I'm going to also drag out our gauge nodes for the temperature and the humidity from here. Our gauge nodes, drag it out. I already have mine out, so you attach it to the temp function and the humidity function, and then you configure them by double clicking. You add a name, temperature, you add a group, and then you just add whatever settings you want. As you can see, I'm using the 3/4 gauge. You can choose from any of the listed ones, and I'm also using a needle style. You can also use a needle style. Then you set your value to message. As you can see, we have string, numbers, expressions, but we want to get messages, so we set it to message. And if you remember, when we're configuring our functions, we added a payload, so you set your message to payload. Then you add a range, 0 to 40, what I used, and then just some colors to beautify the gauge. We'll do the same for the humidity gauge. Also double click, add a name, a group, the type of the gauge that you want, whatever style you want. Also remember to set your value to message and configure it as payload, and then you can choose whatever colors you want for the gauge. Done. I'm going to delete these examples that I used. So again, ensure that each and every one of your nodes are connected properly. The MQTT in to temp function to function, then the temp function to temperature gauge, the humidity function to the humidity gauge, and then the debug. Also, the LED button on and the LED button off are both connected to your MQTT out. And then we go to we deploy our readings. So now we deploy our setup. Just click on the deploy button up here, and to deploy, you have to ensure that your ESP is connected to your monitor, just like that. And then you click on the deploy button, and in no time the readings will start to show just like this. As you can see, we can only see the readings but not our gauge. So to do that, we have to open the MQTT dashboard, the Node-RED dashboard, so that we can see our gauges move as the readings come in. So we open it just like that. I already have mine open in my server. So I switch to it, and you can see the readings change just like that. And we also have our buttons for our LED on and our LED off. So guys, now I'll walk you through the software setup. So up here we include our libraries, the Wi-Fi library so that we can connect to the internet, the POP-sub client library so that we can connect to a broker, and then the DHT library. So we define our pins, the DHT4, our DHT is connected to the GPIO4, and then we also define our DHT type, DHT11. Then we create an object for the DHT class and add our pin and type. Then we'll also create an SSID and a password so that the ESP32 can connect to a Wi-Fi. Then we declare our MQTT server. Like I said, we're using the broker.imq.com. We'll also declare a pin for our LED. We're using the onboard LED for the ESP32, and that is the pin 2. So now we create a void function to connect to Wi-Fi, just like this. So while the Wi-Fi is not connected, it waits for it to connect and serial prints its local IP. Then we move on to the callback, and the callback lets us see if a message has arrived, and then it prints the message. So if the message contains an on, it triggers the LED pin high, that is on, and if it contains an off, it triggers the LED pin low, that is off. We also declare an object for the Wi-Fi client and the POP-sub client, and we move on to our setup. We initialize the serial monitor, and then we set our pin to output. We initialize our DHT begin. We'll also initialize our Wi-Fi begin, then add in our SSID and password. And then we call our connect to Wi-Fi function. Now let's test everything live. Log in your Arduino, your ESP32. Okay. Wi-Fi is now connected and readings are displayed. We move over to the dashboard and see the readings displayed in real time. Yeah, the temperature and the humidity gauge change periodically. Now we test the on and off button for the ESP LED. Yes, we trigger the ESP on. Now we trigger the buttons on and off. So the onboard LED for the ESP is on now, and we'll trigger it off. Now the LED is off. In this project, we successfully designed and built a smart IoT environmental monitoring and control system using ESP32, MQTT, and Node-RED. We were able to measure real-time temperature and humidity, transmit data wirelessly over MQTT, visualize data on a live Node-RED dashboard, and remotely control an LED device from the internet. During the testing, we confirmed that sensor data is transmitted in real time, the Node-RED dashboard updates automatically, and the ESP32 responds instantly to remote commands. This system demonstrates how IoT can be used to build scalable real-time monitoring and control systems for smart homes, automation, and industrial applications. If you found this project helpful, don't forget to like, share, and subscribe. For quality electronic components, check out Up360 Circuits. Thank you for watching, and I'll see you in the next project.